I have some problems on the board that we've been working on in here. Just share them with you. We'll use camera 2 probably to take each one at a time, and so we'll put them on the board. People are working on them in here on paper, and they're from 3 units. We've been reviewing all week on the units we've done up to this point. And so I decided to take 3 problems from 3 units, 1 the counting unit, 1 the simple interest unit, and 1 the how much unit. So let's cut to the first problem from counting. Okay, so basically it states, as I come off to the side of this, we're going to start with this number on base 10. So it's 144. It's called a gross in the business community. And I want you to give this value in base 3. So you can sort of get that jotted down, and then I will go ahead and look at each of the others. So if you're at home doing this and you want to write these down and participate, the idea is you're counting unit, you're in base 10, 144, but I want you to write it as a base 3 number. Hint, place values and division would help. Okay, let's slide over with that camera, and we'll pick up the next one as we go over. This is in simple interest, and so you may want to come up just so, there we go. We're going to deposit $5,000. You're going to do it in like a CD or something of that nature in a bank, and we're talking about a 6% interest rate, and we're going to do it quarterly compounding. And I want to know the balance at the end of 3 years. So you want your balance at the end of 3 years, quarterly compounding, and I want you to use the calculator for this. So this is just straightforward using the calculator to get your answer. And then as we slide over to the right, the last one, and this is just a pretty straightforward problem, but I want it set up with dimensional analysis. And so it reads, if I plan to ride my bike to Los Angeles, roughly 300 miles, over the holidays, and I'm going to go 10 miles per hour, and I'm riding 10 hours a day. So I think I've sort of got my head between things so we can read it. Plan to ride the bike to Los Angeles, 300 miles, over the holidays, 10 miles per hour, 10 hours each day, and how many days will it take? So that's the last problem. Let me just walk off camera in that one so you can see it a little bit better. Those are the 3 problems. So I'll just leave that one up on the board for a moment, and then we'll probably leave that up for about 30 more seconds. Then we'll come back to problem 2, panning back, then pan back to number 1. So each one is on the board, trying to give people an opportunity to do those. You want for those of you in here, make sure your name is on your paper on this, and you'll be turning that in to me. So these are 3 more problems of the kind we've been doing, and we're just going to leave that one on the board for about 10 more seconds or so. Then I will have Will pan to the left, picking up the second problem on simple interest. So he'll go over to the side on that one. Okay, let's pan over. Thank you, Will. Nice transition there. There we go. That's the next one. The hint here, for those using the calculator, we've been doing these problems in class with that calculator. You're using the M+ key and the MRC key. And I just want the amount in the bank at the end of 3 years with quarterly compounding. And we'll leave that up for about another 15 seconds. Okay, let's start a smooth transition to the first problem. Okay. And this was the counting unit problem. And we start with a 144 as a base 10 number, the way we'd usually say. That's 12 dozen. But I want you to give me the value in base 3. Okay, so that's the last problem of the group. We'll leave that up for a few more moments, and then I will go back to the board in a moment. And then when I'm back there and we center in on what I'm doing, then for the most part I will be looking at other problems from the document cam. So we'll sort of bounce back and forth there. And then once we do that, just for a few more problems, I may take time to then cover these problems on the sideboard, but that's the transition we're going to make. So the idea is I come back to center now, and we take those problems so that you just have what you've written down. The idea is I'd like you to show me what you can do in those. And while we do that, as you finish up in that, I'll give you a few more moments. I'm going to make a transition to a few problems just to look at short answer kinds of questions in each of the units. So what I'm going to do now is look at what's online as short answer questions. So as we now go to the document cam, you may want to have some other notes if you're done with what we're doing there. This is the first problem in this set. I'm going to move the computer over just a little bit and then try to, let's see, I think I can probably bring that in one more level. Okay, here's the question. As I look at that, and I'll scroll down here a little bit so I can just see that. So the question is, what digits are we going to use to write a number in, and here's the base 8. So basically digits used to write a number in base 8. So I think you can probably do that one in your head. So think about it for just a moment. What digits would you use to write a number in base 8? Okay, so we can come off there. And my guess is you have that now in your head. Somebody want to give me an answer for that? The digits you use in base 8. 0, 1, 2, 3, 4, 5, 6, 7. Okay, 0 through 7. 0, 1, 2, 3, 4, 5, 6, 7. Not a bad answer. Works out pretty well. Now let's see what else we can do here. Again, what I'm going to do is scroll down and see if we can find another number. As I look at that, here's a pretty short one in terms, again, short answers. That's what I'm hunting for. Short answer kinds of solutions. We're going to give the place value for each digit. So as I come across here, the question is going to be, what base? So if I'm in base 4, we have just 4 spaces that you can see in the screen. That's enough. I'll come over just a little bit so we can center it a little bit better. What are your place values for those first 4 place values in base 4? Again, you can probably do this in your head. And that's the intent here. Short answer questions. Just trying to keep in mind as we think of reviewing some short answer problems in the counting unit. Okay, does somebody have an answer for me there? The first 4 places going from right to left. Who will give me the values there? From right to left. The first digit on the right is going to be what place? Always. The ones place. Next digit is always what? Your base. So this time 4. The next digit you get by multiplying by? 4. So what's your next place value? 4 times 4. Think of multiplying, not adding. 16. And then your 4 times 16? 64. Okay. So you would have 1s, 4s, 16, and 64. Okay, well let me come off there for just a moment. And what I want to do is swing down. Okay, that's that first set. I'm going to back up for a moment and get a different set of problems. Okay, and let's see what we have here. This is one that we've had troubles with in the past. Let me just bring it up on the screen a little bit larger. Okay, now this one, what I'm interested in is we go to the screen. I want the next number. That's, again, a problem you can do in your head. So the next number, and after what? Here's my number. Given 7, 7, 7, base 8, I want to know the next number. So I want that as something you do in your head. So the idea, and you could write it down on paper, but you should be able to give me the next number without any real work, just doing it in your head. So I'll give you a moment more to think about it. Okay, who has this one? As we come off to that for a moment. We have 777 base 8, and I want the next number. Okay, who has it? Adrian? Okay. The first statement was not the way I wanted to hear it. The second one is the way it should be heard. 1, 0, 0, 0. Again, looking at our number, you had a 777. The next number, you add 1, and you're in base 8. So your 1 plus 7 is a 1, 0. You carry a 1. So at the end, you have 1 with 3 zeros after it. So as we come off there, don't read it as 1,000. It is 1 followed by 3 zeros. So we would say 1, 0, 0, 0 or 1, 0, 0, 0. Okay, that's good. So we've had a few problems there. Let me see if I have anything else. And this one is, again, no, I don't want that one. Let's see if there's any more in this set before I go on. Okay. Those are the short answer problems that came out of that unit. Now, what I want to do is go to the sideboard, and we're going to look at the problem I just asked you to do. But before I do that, I'd like you to turn your papers in now from that short effort we made at the very beginning. So if you'll pass those over, make sure your name's on it, and pass them over to the side, and then the person at the end will pass them forward. So quickly pass those forward, please. And then what we will do is I'm going to answer those. So we got any more coming in? Okay, paper with name. And pass it over. Monica, could you take that as Lewis passes it over? Okay. Okay, thank you. And just goes over here at the end. Now, what I want to do, as I say, is go over to the sideboard, and I'll just let you make the transition now. I'll walk over to there. And the question was 144 as a base 3 number. So I started with 144. So we start with 144. I call it base 10 just to remind you it's the usual number that we would write. How do we do this? What do I have to have if I'm in base 3? So I want to write as base 3. So the question, what do I need? Place values. Which place value do I want? Base 3. And what in particular? If I think of the place values, they are the 1s, the 3s, the 9s, the 27s, the 81s, the 243. Do I have to keep going? Which one am I going to focus on? The 81 was the answer just given to me. That's the largest place value I could have for 144. So I'll just divide 81 into 144, and it goes one time. I subtract, and I have a 63, correct? So I know I can't have any more groups of 81. The next place value I want to look at is the 27. So the question, how many times will 27 go into 63? The answer, twice. Agreed? So that goes in twice, so that's a 54. And I happen to have what left? A 9. So I have one group of 81, two groups of 27, one group of 9, no groups of 3, and no groups of 1. And so this is my number in base 3. Okay? Any questions? If we check it, 1 times 81 is 81. 2 times 27 is 54. 1 times the place value at 9 is a 9. I have 0 3s, that's a 0. 0 1s, that's a 0. I have a group of 10 there, and so that's a group of 10 plus the 4 is a 14. Then the 9 and the 5 is a 14, and I'm at my 144. Okay, I'll just leave that on the board. And I'm going to go back to the front, and we're going to look at another set of review problems. What I have in mind here is coming to the how much. And so let me click on that, and let's see what we can do here. Okay, I don't like that particular set all that well. Let's go to the second one and see if I can find something here. Okay, let me increase the size of the font here so we can do this a little bit easier. I'll get this up high enough, and we'll be there in just a moment, Will. Just take one more moment. Okay, we're on a walk, and that's still not quite as large as I'd like, so I'll just increase the size of it. That looks more readable. You walk 4 miles per hour. Okay, so if you think about that just for a moment, we're located here on campus near the center of town. So if you started walking from here and you started walking north, so you're in College Avenue, you start walking. Let's say you walk over to McHenry from here. How far north could you go if you're walking 4 miles per hour in 1 hour? So you start from here, walk over to McHenry, and then head north, meaning heading out towards where the car dealerships are. 1 hour, where would you be if you're doing 4 miles per hour? Any idea? You'd be very close to Sylvan Avenue just before Barnes & Noble. So if you're walking that fast and you leave from here, you should be able to get to Barnes & Noble, or more importantly, Starbucks, for a cup of coffee or some other beverage at Starbucks at Barnes & Noble. So that's to give you an idea in 1 hour how far you walk if you're walking that speed. Okay, back to the problem. So the question is, if you're walking this fast, let's take a different walk. We have a track out here next to the buildings we're in right now, the football field and the track. This is where the Cal Relays have been run since 1941. Okay, so we have had 60-plus years of the Cal Relays, and one of the nationwide events, the international reputation for track and field. So let's say you go out to that track and you want to run the 440. Well, you're going to walk it. Okay, so you're going to walk the 440. So the question, as we come back to the fact that the track, you're going to walk in that track and you're going to do a 440. So the question is, how many what? Because this becomes the important part as to what I'm going to set up. How many minutes? So the question, if you walk 4 miles per hour, how many minutes to walk that 440? We know that you can go from here to Starbucks in an hour. But how long, how many minutes can you or will you need at that pace to go around the track for a 440? So we'll give you an opportunity to think about that for a moment. Remember, there's 1,760 yards in a mile. So this is about what? 1/4 of a mile. So you should know the answer off the top of your head. I'll give you a chance to work on that. We'll set it up. So how many minutes? That's the question. We'll give you a chance to set it up because it's very important that you have that opportunity to set up the first part. Once you set that up, the rest is a what? Should be directed. What we call a guided walk if you're out on a nature trail. Tells you where to go, what to see, what to watch. Same idea. Okay, let's come to the sideboard. So what information do we have? Well, we have a 440. That's what we want to walk. The 440, so 440 yards. And I want to do it at 4 miles per hour. So 4 mph. Do I have any other information that I need for this problem as far as setting it up? Well, since I wanted minutes, that's how many minutes I want. What other equivalents do I need? 1 hour equals 60 minutes. So if I have that much information, I should be able to set up the problem. What should be in my first numerator? Minutes. So I know I want minutes in the first numerator because I want minutes at the end. That's where I'm going to use the fact that what? 60 minutes, 1 hour. Okay, now the second fraction must have what in its numerator? Hours. And it's because I have 4 miles per hour that I'm going to use that first information, but it's 1 hour in the 4 miles. Okay, so I have that information. The hours now cancel, but what must be in the next fraction? Miles. Okay, so I need a miles here, and that's where we have this equivalence that says what? 1 mile is 1,760 yards, and then finally I need that I have a 440 yards over 1, the yards cancel. So my numbers, 60, a 1, a 1, a 440, and that's over a 1 times 4 times 1760. Okay? Now how many times will 440 go into 1760? Anybody? I want to cancel here. 440 into 1760 goes 4 times. Now I have a 60 here. I have a 4 and a 4. Can I cancel anything with the 4 and the 60? Okay, the 4 cancels here. It gives me 15 here. So I'm ending up with what? 15 over 4. What is that as a mixed number? 15 over 4. Divide 4 into 15 in your head. 15 over 4. You got 3 and 3/4 minutes. 3.75 would be acceptable. Yes. Okay, leave that up there just for a moment more, Will. Historically, or hysterically, but historically, let's reflect on that just for a moment. Let's come back to me. Roger Bannister, a runner, did something that was very special many years ago, something that people didn't think would likely be possible. Anybody besides Will and I know what it is? Roger Bannister. God, I'm thinking, what, 40-some years ago? 50? 50 years. He ran a 4-minute mile. Now, this is nearly 4 minutes for what? A quarter of a mile. In fact, yes, quarter of a mile. So he ran it a whole mile in about those 4 minutes. And this at 440 is 1/4 of the 1760. So this is a quarter mile, and you took roughly 4 minutes. So puts it in perspective. I don't know what the current record is, but I know it's under 4 minutes. And my guess is it may be getting down to that 3.75 or something like that for a mile. Interesting problem. Okay, now, what I want to consider is the problem we had on the board. This was the dimensional analysis. So if you could, we'll bring camera 2 back over here so we can just see that for a moment. And then I'll talk about it. And what I will probably do is erase what was behind me in the counting problem. I don't want to erase that, do I? Because I want to take pictures. Okay, nevertheless, we will go to this problem. And we'll bring that in so you can see it one more time. This is the how much unit. Okay, so doing a little better than 4 miles per hour. We're riding a bike, but not all that fast. Okay, this is your leisurely ride, Saturday afternoon kind of ride. So what I'm going to do is look at the setup here, and we'll just look at it at the top of the board. I wanted to know how many days, correct? So my first fraction will be days. Okay. Now, what do I have that I can use here? That 10 hours is the equivalent of 1 day. So I will have, probably I need to do that more over here, 1 day over 10 hours. And then what I think I will try doing is shortening up that just a bit so I can get more space available. Next fraction has to have what in it? Hours in the top. Now, do I have anything else with hours? I have 1 hour with the 10 miles, correct? So I'm riding in 1 hour, 10 miles. So I have the hours canceling. Next fraction has to have what in it? Miles in the top. And how many miles would I be riding? 300 miles. Over what? The miles cancel. And of course, what do we get? 300 over 100. There's your 300 here, and I have 10 times 10 is 100, so I get 3. So if I leave on that ride on Thanksgiving morning, that's Thursday, Friday, Saturday evening, I'm there, and Sunday morning I can put the bike in a car and drive back. Well, I mean, Thursday's the holiday. Now, if I have the turkey dinner first and then leave on Friday, I'm riding Friday, Saturday, and Sunday and fly back Monday morning. So it's a little bit hectic. So maybe I should ride more than 10 hours a day. Well, the grapevine, yes, that's a little bit of a problem. You better eat a lot of turkey before you go up the grapevine, okay? We got it? Again, dimensional analysis. Okay, let's go back to center, and let's see if we can do a different review. Okay, that was in the how much. We did a couple problems there. And as a percent problem, I'm going to look at that. Let's see. Here are some short answer problems in a moment. Let's see if I can get the ones I want. Don't want that group. So again, I'm looking for a particular set of problems. And in this set, as I look at these, let me get the size of the screen so you can see them very easily. We'll get that going here in a moment. Okay, I've got 2 of them to double your pleasure. 33 and a percent to a fraction is what I want there. So let me try just giving that just a tweak there. There's your fraction. 33 and 1/3% to a fraction. And I want you to change 0.075 to a percent. Those are your 2 problems that I think you can do in your head this morning. So let's see what you can do in your head. Just knowing the information. You can write down your answer, but that's what I want to do. Now, Will, let me tell you where I'm going next. Okay, what I will do is again go to the sideboard probably after we use camera 1 to probably come back to what I have there. So when I finish this that we're doing here and have a few more such examples, then we'll center, come back to the document cam, go back to the board, and then camera 2. So it should work out. He says in the fine print. Okay, who has an answer for the first one? 33 1/3% as a common fraction. Anybody? Louder so I can hear it. I heard somebody say it. Nobody's brave. 33 1/3%. What does a store advertise instead of saying 33 1/3% discount? They will say it something off. What? 1/3 off, precisely. 1/3 off. So your fraction is 1/3. 33 1/3%, 1/3. Back to the document cam. For your .075 as a percent, who wants to take? Chris, did you want to do that one? No. Heavens to Betsy. Okay, the answer was a profound no. I want this as a percent, .075. What is it? 75? Can't quite go with that. 7.5%. Very good. Another way of saying that. Instead of 7.5%, another way. 7.5%. Very well done. So 7.5%. Let's go back to the problem one more time. So .075 you could write as 7.5%. Okay, coming off there, Will, for just a moment. One more of these to come up. Not that set, so let me go back and go to the next part of that review. There's a third one here. And let's see what we can do here. Do I have anything there that appeals to me? Not there. Again, hunting for a very nice short answer response. Let's see if we can get anything here. Let's see, this is one we've been talking about. Remember when we talked about taking a payoff and simple interest and you do a 10% of what you owe? Okay, that's where I'm headed. So I'm reversing the problem in this way. Okay, we're getting there. Okay, here is the problem I'm going to have. Well, we're getting close. And just about there. I like that. We are there. Okay. Fill in the blank. So your payment is $25. What was that 10% of in your head? Should be able to do this without reference to the calculator. So without reference to the calculator, could you get it in your head? 10%. Don't say it yet. 25 is 10% of some number. So if you paid $25 on your bill and it was 10% of your bill, what was your bill? This is working backwards. Give you another moment to reflect on this. Give you another moment to reflect on it. So what I'll have you do, Will, is come back to me on this camera 2, and then you'll be able to center camera 1 on the simple interest problem. You're there. You're ahead of me. Okay, coming back to me on this one. What was your answer? $250. Excellent. Because if you had $250, so you owe $250, and you're paying 10%, then you would move the decimal over one place to the left, and you would get $25. Make sense? Or dollars. We're going to look now at the third problem we had in the front board. So we'll bring in the simple interest problem. You're going to need your calculator here. So remember, we have 6%. So let me write this invest, deposit. So it doesn't necessarily have to be in a bank, but in some way, you're making a deposit. As we go to the sideboard now, we're going to deposit $5,000 again. And we're going to do it at 6% interest. By the way, what is 6% as a decimal? 0.06. So we've got to remember that. So this is at 0.06. And I'm going to have what kind of compounding as we go back to the front board? Quarterly compounding. So that means 4 times each year. So for quarterly compounding, I'm going to abbreviate that. And then, how many years? So we said for 3 years. And I want to know what? Final balance. Okay, so it says give the balance. So I want at the end. So at end of 3 years, I want how much do I have in the bank? How much in the bank? So what are we going to do with this problem? We're going to use a calculator. Does anybody need a calculator to do this? I have a few extras up here. Anybody need one, or we're okay? Okay. Now this is the calculator where we're talking about the M plus and the MRC, memory recall and M plus. So what are our steps? Somebody give me the steps. Okay, I put the percent, which is 0.06. Then what am I going to do? Divide it by what, though? By the 4, the number of times I compound a year. So that's divided by 4. Then I'm going to hit equal key. By the way, at this point, I should be reading this. So I should be reading that in the calculator. Now what do I do? Add 1 and hit equal key. What will I read there? 1.015. Then I hit M plus. This stores it into memory. Okay, now I'm going to enter. I'm going to use E for enter. My $5,000. Then I'm going to hit times MRC. How many times? Be careful. 3 years. Compounding quarterly. So what? 12. So I do this 12 times. And then hit what? The equal sign. Okay, let's see what you get. Or what we have in the bank if that happens. What do we have in the bank? So I will, and by the way, we expect more than 5,000. We did this for 2 years yesterday, and we ended up with what? 5,300 something? Okay, so you're arguing what value, Adrian? But we don't have a, you're going to take Chris's calculator. Chris doesn't mind at all. Chris is saying, take it. And of course, while we're doing that, just think of what you can do tomorrow for your Thanksgiving dinner, talking about how much, how many slices per person, how many ounces per slice, and so on. Okay, Travis, what do we have? $5,889 and what? 75 cents. Rounding up. The bank won't do that. Sorry, it's not Christmas, it's Thanksgiving. So we have a 0.74. So $5,889.74 in 3 years, you gained $889.74. 3 years. Okay, any question there? Okay, well, we'll let that go. And time for a few more short answers. Did anybody get all 3 of those right? Oh, boy. Okay, we had 3 questions at the beginning, and nobody aced them. Okay, new, short answer. We only have a few more moments to do this, so we got to make the best we can of the time. Let's see, what have we not looked at yet? Formulas. Let's see what we could, oh, that one you don't want to do. I'll show you what I'm looking at, and you'll just tell me you don't want to do this, I'm fairly certain. Here's the diagram, and I would want you to find the area of that. But I have a hunch with the time we have left, that's a bit much to do in your head. Well, yes, I thought so. So let's see if we can get something a little more comfortable. Let's see. Let's try this one. Can we... this is not making me feel much better. Here's another variation on it we could have done. Nah, I don't want to do that. Okay. There's got to be one of these that we can do in a short answer format. Oh, yes. Here we go. Let's see. Let me find one of these that's nice and short. Oh, I like this one. Okay, I found one. I'm a happy camper. Got to make sure we get this one set up right, and I think we're in business. Okay. The volume of a sphere whose radius is 3 meters. By the way, 3 meters across is about 3 yards. That's about 10 feet. That's a pretty good-sized hot air balloon. Okay, so I want the volume. Big balloon. Radius of 3 meters. I'd take that back. That's just a radius of 10 feet. So that's a diameter of 20 feet. That is a good hot air balloon. Okay, so what's the volume of that puppy? Draw me the shape, give me the formula, and show the substitution without worrying about the answer. So I want the formula, the shape, and the substitution. That's what I'm asking you to do. And we have a minute and a half that you can do that. So we'll see what we can do with our time. Okay. So tomorrow, if you want to entertain the guests at the dinner table, you can ask them problems like this. Short answer questions. It's better than politics. There is no height here. This is a sphere, not a cylinder. A sphere. Okay, you're thinking of pi r squared h from yesterday. Okay, and remember, as we come over here now on the side, when you think of pi tomorrow, what's your challenge? Not to think about 3.14 as you look at that pumpkin pie. So pumpkin 3.14, apple 3.14. Okay, what is my formula? It's volume, and give me the formula for a sphere.
Pi r cubed.
Yes, it has pi r cubed in it. That's not enough.
3/4.
No, you got it upside down, 4/3. So 4 over 3 times pi r cubed. What does this sphere look like as a diagram you draw? A circle that is shaded, or as I draw an effort at a circle, that looks like a pi too. Okay, and then I do what? I run something like this, ovals inside, making it look three-dimensional. And then, what is my substitution going to be? V is equal to 4 times 3.14 times 3 meters. So it's going to be 3 cubed, and that's over 3, and that's meters cubed when we get done. So that's 3 into 3 cubed goes 3 squared. That's 9. So 9 times 4 is 36. So the answer here is 36 pi cubic meters. That is one way of doing it. And if you multiply that out, what number do you get? Something around 110? What do you get? How much? Oh, 113. Okay, it said 130. 113.04? 04 m to the third. Okay, so that was our last problem. Now again, enjoy Thanksgiving. Think of formulas when you eat that pie.